Hello. So I want to introduce the functions we need to know for this course, and then maybe give a little bit of overview. What is this course going to be covered? So the functions we need to know for this course, the first one is called the polynomial functions. Poly means many. Polynomial. Nomial means mathematical terms. So poly means many. So many mathematical terms. So what is a term of mathematics? We could have a number, right? This number could multiply by a variable, let's say variable x, or maybe we'll have another variable y. Maybe we have what we call this coefficient. Maybe this y has a coefficient, which means y multiplied by 3. But we could have something else. And then in this case, how many terms we have? We'll have this one as a term, this one as a term. So the plus and minus, or sometimes maybe we'll have a minus, right? Plus and minus. So plus and minus separates mathematical expressions into terms. So this is a term, this is a term, well, this is a simple term, right? Or maybe I have 2x minus 1 divided by x plus 1, right? So this, we treat this one also as one term. So this means 2x minus 1 divided by x plus 1, right? This which is another way of writing it. So what is the rule of thumb? The rule of thumb is multiplication and division glues the terms together. Let's say 2 and x, right? 2 and x means 2 multiplied by x. So x is being doubled. So that's multiplication. So the multiplication acts as a glue. So glue these 2 and x together as one term. Same thing for 3 and y. And in this case, we have 2x minus 1, but seems like 2 terms, we call binomial. It is 2 terms. However, when we do division, we group those 2 terms in a group. So now we put them in a group. So 2x minus 1, we treat it as one group. And x plus 1, we treat it as another group. So total together, we can treat it as one term for the moment being. So of course, this expression can be written in different ways. Then in different ways, there may be more than one term. It could be written as 2 terms. So what do I mean by that? So I could rewrite this one as 2x divided by x plus 1 and minus 1 divided by x plus 1. Right? Remember common denominators? So x plus 1 is a common denominator of the term of 2x and of the term of minus 1. So if I write this way, you see these are 2 terms, right? 2x divided by x plus 1 is one term. 1 divided by x plus 1 is another term. All right, so nomial means, so these terms, right? So poly means many. Well, this is a polynomial, right? Poly means many. But when we talk about the polynomial functions, right? So what is a polynomial function? We only deal with one variable, right? This usually we call this variable x. So let's just give some simple example, some function you already know. Let's see, in high school, we read y equals to 2x minus 1. Remember, this is called the slope intercept form. Like intercept means y-intercept, means 0, -1. But when x equals 0, 2 times 0 is 0, so y equals -1. So this is y-intercept. Y-intercept means the points on y-axis. Right, 0, -1, so the points here. So points on y-axis called y-intercept. Points on x-axis called x-intercept. So in high school, we call this slope intercept form. But when we talk about polynomial functions, so this is one of the basic polynomial functions. We rewrite y as function, right? So function of x. So which means y is another variable, depends on the variable of x. But if you give me one x value, I can evaluate y. So y dependent on x value. So in the function world, we write y into f of x. So f of x. So 2x minus 1. So this is a polynomial degree 1, right? Polynomial degree 1 function, or we call linear function. So that's one thing about mathematics. You know, one same thing has so many names. So linear function. So polynomial degree 1. So where does the degree 1 come from? So by default, x, so the variable x by default equals to 1 times x, and x raised by 1, and x divided by 1. Right? 1 times x, still x. X raised by 1, still x. X divided by 1, still x. So x can be written in all those different forms. So in this case, so x raised by 1 means the degree of x is 1. So in here, we see the x degree is 1. So by default, right, x raised by 1. So that's why it's called a polynomial degree 1. Or maybe we have another function, just -1, right? No x. So this function does not depend on x. So we call constant function. We call polynomial degree 0. Degree 0. Why? Because x raised by 0 equals to 1. Right? X raised by 0 equals 1. Okay, so keep going on, something called a quadratic function or polynomial degree 2. Maybe you have seen this, right? X raised by square, maybe minus 2x, maybe plus 1. I'm just making this up. So what's important is this leading term. This is called a leading term, which has the highest exponent, right? The exponent of this x is 1. So this is a polynomial degree 2, or so on and so forth. When you see the highest exponent in the function is x raised by 3, that's polynomial degree 3. X raised by 4, polynomial degree 4, so on and so forth. So that is a family of polynomial functions. We have to know this function very well. So I hope you follow the video, do your homework to really understand this family of functions and understand some terms go along with it. So that's the first type of functions covered. So also, when we talk about functions, we talk about expressions, right? We also talk about graphs. So if it's a function, we can always graph it, right? Constant function, like let's say f of x equals -1, that's just a horizontal line, right? Let's say -1 is here. So what is f of x equals -1? That's this straight horizontal line. Well, linear function depends on the slope, right? If the slope, let's see, 2x minus 1, the slope is 2. So which means when y is 2 times bigger than x, well, plus minus, well, in this case, -1, right? So when x equals 0, so we get this one. Right, so we graph this one, what f of x equals 2x minus 1, we'll get this straight line, goes this way. So that's a degree 1. Well, degree 2 is, it could be upward parabola or downward parabola. Right? Maybe some of you already know quadratic function, right? We call hyperbola, a parabola, upward parabola, downward parabola. Right? Then degree 2, that's degree 2. Degree 3, we will have 2 wiggles, right? It could go this way. I'm sorry, it's difficult to draw it, right? Or it could go, it just wiggles twice. So let me make wiggles upwards. Or let me actually start from here, right? So it's like one piece of string. So polynomial function, when you picture it, is one piece of string, right? You think you can pick this one, you see this one piece of string. So that's polynomial function. That's how you picture it. So when the degree goes up, the one piece of string wiggles more, right? If it's a polynomial degree 3, wiggles twice. Polynomial degree 4 wiggles 3 times. So wiggles means the strings goes ups and downs, up and down, up and down. Okay, this one actually wiggles 3 times. So this one should be polynomial degree 4. Because this I draw wiggles 3 times. But wiggle 1 time could be like this. I could wiggle 2 times, right? Could be wiggle this one, wiggles like this. All right, so that's polynomial function. And of course, you can ask ChatGPT to show more. You can go to YouTube video, more than other than the textbook. So this is polynomial function, right? So give you typical example. Let's see, I have polynomial degree 4. Maybe I have 4, x raised by 4, minus 3, x raised by 3, plus 2x squared, minus x, plus 1. I'm just making this up. All right, those numbers called coefficients. Coefficients of the variable can be any numbers. It can be any numbers. What's important is this leading term, which means the term has the highest degree. So this is polynomial degree 4. All right, with polynomial function, the second type, I'm going to erase this. Of course, you can always go back to watch it. The second one is called a rational function. Where does the word rational come from? Okay, with the numbers, when we talk about numbers, we have something called real numbers, and we have something called imaginary numbers. Imaginary numbers means I square, we made this I square equals -1. But with real numbers, any number, when you square it, it has to be at least 0. So those are the numbers we use in life. Okay. And typically, under real number, we have 2. One is called a rational, one is called irrational. What does rational mean? Right? Rational means something makes sense to human brains. The humans can understand, can perceive the information in the number. Let's see, 1 divided by 2, or 1/2. Right? We understand this number perfectly. 1/2 could be 1 apple, right? We cut into half. You get a half, I get a half. So this one is a half apples. Same thing like 1/3 or 2/5, so on and so forth, right? The denominator is the whole thing, right? Maybe I have 2 of something. You take 1, there's 1/2, right? Maybe we have 3 of something, right? Maybe 3 people share one pie of pizza, like so on and so forth. Maybe one pizza sliced into 5 equal parts, and you ate 2 slices. So which means you ate 2 out of 5. So those numbers, right? Numbers can be written as a fraction. Numbers can be written as a fraction. Are called rational numbers. Rational means, we understand. It totally makes sense to human brains. Irrational means it doesn't really make any sense, but however, it works. Right? Let's see pi. 3.14. Okay, those are the digits I could remember. Right? It keeps going on. It keeps going on. And there's no repeated pattern. Right? And there is one machine, I think in IBM, still calculating the digits, the next digits of pi. Right? Okay, so those numbers, there are many of these kind of numbers. Let's see, square root of 2. Right? Usually we approximate as 1.41 something, right? Like an Euler number. We're going to use Euler number for this course as well. right? It's called a natural number or Euler number. Euler is a great mathematician in history. So he found out this number. So that's why this number is named after him, Euler number. It's about 2.718, keeps going on, just like a pi. Okay, so we have many of those numbers. We don't really know them exactly, but we can approximate. Right? We use the approximation of those numbers. So later on, we're going to learn something called natural logs, regular logs. Let's say ln2, right? Those numbers, we don't know exactly what the number is, but we use approximation. All right. So that's where the rational comes from in mathematics. Okay, when we talk about rational, that means that. So rational function means what? Remember, we have a polynomial function, right? So the function we're going to use f of x, g of x, right? K of x, h of x to represent. Okay, we use different letters, but with parentheses, open parentheses, x, close parentheses to mean the function depends on x. So, but most of the case, I'm going to use f of x, unless I have to have two functions. Maybe I use one function as f of x, another function as g of x. So let's say f of x is a quotient. Quotient means one thing divided by another thing. So on top, we call numerator. In the bottom, we call denominator. Or when we write as one, let's see this one, right? This one can be 1 divided by 2. In this case, we call this a divisor, a dividend. We call this a divisor. Well, when we write in this case, the top we call numerator, the bottom we call denominator. Right? So the numerator is a polynomial, can be any degree. The denominator is another polynomial of any degree. Right? So given an example, I may have 1 divided by x, very simple one. Right? So the numerator is polynomial degree 0, constant function. The denominator is polynomial degree 1, linear function. Right? Maybe I make another example. I could have x divided by x minus 1. H of x, I could have 2x squared minus 1 divided by x squared minus 2x plus 3, or so on and so forth, right? So the numerator is a polynomial, the denominator is a polynomial, and we call rational function, right? Because it looks like a fraction, right? It looks, I have a denominator, I have numerator, looks like a fraction. So we call rational function. And for rational function, what's important for us is typically very important is the denominator, right? Because in mathematics, we don't talk about one apple shared by nobody. It won't exist. It does not exist in mathematics, right? It's not interesting. One apple on the table, nobody wants it. So that's 1 divided by 0. We're interested in one apple shared by 2 people, one apple shared by 3 people, but 2 apples shared by 5 people. So if the denominator becomes 0, it becomes prohibited in mathematics. So it's illegal in mathematics. You cannot have expression, anything divided by 0. So that just does not exist in mathematics. All right, so what do we concern about this? Let's see the first one. So we have a word for it, and then call this word domain, call this term domain. Right, domain. Domain means all the x value makes this function legal, right? So in this case, we see x can be any number, but it cannot be 0, right? Because if x is 0, there's 1 divided by 0. It's prohibited in mathematics. It does not exist in mathematics. So we see domain of this function is x not equal to 0. Maybe we use a set notation to bracket. So this means X can be any number, any real number typically. Usually the functions for the basic function, we work in the real number world. So X cannot be 0, but X can be any other number. So that is the domain. What about this one? The domain of this one is X minus 1 cannot be 0. We solve for this, we move -1, we add 1 on both sides. So that means X cannot be 1. Because if X is 1, 1 minus 1, that becomes 0. It costs 0 in the denominator, which is illegal in mathematics. So the domain, we see the domain of function g is X not equals to 1. Right? For the third one, h of X is a little bit complicated. We'll talk about more. We'll talk this more. Right. This is involved in solving a quadratic function. We'll talk more about this. Right? We want to see what kind of X value will cause this function to be 0. Right? Not to be 0, there's so many. So we just want to find its complement. Right? Once we find the value to be 0, so the domain is all the X values, not the ones cause the function to be 0. So this is rational function. All right. So which is a polynomial function divided by another polynomial function. Then the third kind is called exponential function. So exponential function, usually we write as, we all in business, right? We try to talk about making profit. Everybody wants to have exponential growth, right? If you ever did a lab, if you have some experience working in a lab, you know the germs, right? The die-out rate is exponential decay. So the exponential function has a form of the function in terms of x equals to, maybe let's use a, just a number, multiplied by base raised by some exponents. You can imagine a is some number, b is some number, the x is a variable, right? But x is in the position of exponents. So that's how this function gets its name, exponential function. Because x is different from polynomial function, rational function, where x appears in the base, right? In the place of b. So b is a base. Then what do I mean by that? If I have 2 raised by 3, 3 is exponents, 2 is base. Right? So given some example, we have this very famous function called 2 raised by x. This is called a doubling. Let's give some values for x. Right? If x equals 0, f of 0 equals 2 raised by 0 equals 1. If x equals 1, f of 1 equals 2. Obviously, 2 doubles 1. Right? If x equals 2, f of 2 equals 2 raised by 2 equals 4. Or 4 doubles 2. Right? So on and so forth. So that's how it gets its name, doubling. And you can imagine if we change the base 2 to be 3, that would be tripling. Right? Every time we increase x value, increase by 1, the value of the function triples. And so this we call, if we draw the graph looks like this. Exponential growth. It grows very fast. Right? So conversely, we have a function we call halving. We have 2 raised by negative x. So this is called a halving. Right? So we can also give some values. So f of 0 equals to 1, because 2 raised by negative 0, still 1. F of 1 equals to 2 raised by negative 1. What is that? Remember, that's just a notation of half. Right? F of 2 equals to 2 raised by negative 2. Well, that's 1 raised by 2 raised by 2, which is 1 over 4. You see, each time when x value increased by 1, the function value decreased by half. So if we draw the function, that's exponential decay. Right? When x increases, the function value decreases. And it's always half of the previous one. So the doubling model, halving model are very powerful in live applications as well. So this is exponential functions. Then the fourth one is related with exponential functions. It's a logarithmic function. Okay, so it's just a name, right? Just a name for a special mathematical concept. Just like my name is a Chen. Yeah, who cares? It's just my name. So same thing. What is logarithmic? It's a name. But what does this name carry? Let's think about this. Let's see 2 raised by 3 equals to 8, right? We have no problem to understand this, right? 2 raised by 3 means 2 times 2 times 2, 3 times 8. So we can rewrite this equation, or this equation, right, as 3 equals to log base 2 of 8. Right? So why do we have to do this? Because sometimes our focus is to get this one. Let's see. I can rewrite this expression, this equation as 2 raised by x equals to 32. Right? What is that? Well, simple term, yes. Right? We can do many times. We can try and to get x value equals to 5. Right? We do 2 times 2 times 2 until we hit 5. So we know 2 raised by 5 is 32. But what if we very complicated, right? Let's see. I have 2 raised by x equals to 10. Right? That's going to be troublesome. So how do we find out the x value? So that's why we want to write x equals to log base 2 of 10 as an expression, right? As a number. What kind of number? It's an irrational number. Irrational number. And also for E, we like natural logs. So talking about logarithmic expressions, we have 3 kinds. We have a regular log, which is log base 10 of some value. We have a log base 2. This is for computer science. Then we have log base E, the Euler number. Remember E equals to 2.718, blah, 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 keeps going on. Log base E. So we call natural log. Right? Natural logarithmic. So log base E. And the log base E, because we use it so often, we simplify with ln. Just this. So log base E, we simplify as ln. Let's see. Let's see if we have E raised by 2 equals to a value, right? It's going to be difficult to write the value. So let's write E equals to 2. Let's see equals to K, right? So we can rewrite this expression. Actually, let me rewrite this. let's say e raised by x, right? Because we're in the exponential world before, so we understand that was e raised by x. So let's say e raised by x equals to 100. So how do we find the value of x? So x is log base e of 100. If you want, you can put a parenthesis around the value of 100. E is base. And because you log base e, we use ln. So we just read it as ln 100. Or sometimes if you want, you can keep a parenthesis around the value. All right, so that's ln 100 in this case. So e raised by x equals 100, which means x equals to ln of 100. We can use calculator. So on your calculator, you will see log, you will see ln. All right. When you see log, that's log base 10. When you see ln, that's log base e. Okay. So it's related with exponential functions. All right. If we put it into a calculator, we can approximate. So let me actually put in my calculator to approximate. My calculator is hiding. Okay. Log, right? You see, I see ln of 100. That equals to 4.605 right? Depending on the calculator, what kind of a calculator you have. The decimal places are different. But this is approximation. It's not exact, right? So it's an irrational number. So those covers the 4 functions we're going to be dealing with this course. So I hope this helps.